Okay, good morning, class. Good morning, class. Yeah. So today we're looking at exercise 9.4.
9.4.
3 minutes. Sorry. 9.3. We have done 5 to 8 yesterday, yesterday's lesson. So you must do 9 to 11. No? Is that correct? Hello? 9 to 11. 9.3 now. But it will come in your mini exam, no? Which is the next exam. People, given AB is the diameter of circle center. People, if AB is the diameter, what do we know? Yeah, that's equal, yes. What else do we know? Angle, yes. What else do we know? Angle C is equal to 90. Why? Angles in semicircle. Then we are told that and AO is the diameter of the smaller circle. Hang on. Another diameter. What do we know now? OMA is 90 or AMO is 90. Why? Angle in semicircle. Now remember, somebody said that is equal. So what does this now remind us of? Midpoint theorem, provided that is parallel. So without reading further, we know that we can apply midpoint theorem here. With the fact that C is equal to MA, converse of midpoint theorem, as well as MO or double MO is going to give us the length of BC. Or you can say that OM is going to be half BC, or we can say that OM, double OM is going to be BC. Any one of those. Can you see that, people? Right. So let's read on. AC is the chord of the larger circle cut in the smaller circle at M. Prove that. People, it's child's play, no? Easy. The midpoint. There is exactly what we have stated already. Not so. So of course, the sum is worth like 3 marks or something, 4 marks. So of course we have to label and all of those things. Okay. So where do we start, people? We firstly say that OB is equal to OA. Why is that equal? Sorry? Radii of the larger circle. There. Okay. Then we see that angle C is equal to 90 degrees. Angle C is equal to 90 degrees. Why? Angle in semicircle. Then OMA is also 90 degrees. Why is that the case? Also angle in semicircle. So now we can state the obvious. Since angle C is equal to OMA, which is equal to 90 degrees. Therefore, what? Therefore, CB is parallel to OM. Why? Yes, good start. Corresponding. See that FP is being formed. Corresponding angles are equal. So corresponding angles are. So what do we say? It's placed straight into the midpoint theorem. So the converse thereof, in this case, we can just conclude, therefore, OM is going to be half BC. Why? Why, people? Converse of the midpoint theorem. We can't get easier than this. No? You try and make it easier for a bit. Easier than this you can't get. No? As I said, it's probably 4 marks here, 4 or 5. People, let's look at number 10. Spice up our lives a bit. You bring our x back. No? No? The X is back, space up your leg. Lisa, can you say yes? Right, people, given AOC is the diameter. People, if AOC is the diameter, what do we know? AO is equal to OC, yes? What else? Angle B, 1, 2, and 3, the combination thereof is 90. That's what I want. Why? Angle in semicircle. Then we are told that B and D are two focal points on circumference of the circle. Angle A1 is X. Write the following in terms of X. Remember, this is your radii there, no? So that is also the same. So let's go. A1 in terms of X. If A1 is X, sorry. B1. B1 would be X. Why? Angles opposite equal sides. You all okay with that? Hello, people. Angle B1 is X. Angles opposite equal sides. What must I add here? Radius. Otherwise, you would have to say OA is equal to OB, radius. And then you would have to say B1 is X, angles opposite equal sides. Okay, if you don't want to write the radius there. So I've sorted out A. Let's look at B. B the one O1. People, O1. Are we going to calculate O1? Angle at center is twice angle at circumference, but there's no angle at circumference there. Or there. O1. But the exterior angle is for O2. Interior angles of the triangle, correct. So angle O1 plus 2x is equal to 180. Sum of triangles. And it's triangle BOA. Not so. Or BAO. Remember, they wanted in terms of x. So we take it over the equal sign. So angle O1 is equal to 180 minus 180 minus 2. C. They want you to calculate angle C. I'm going to calculate angle C. Interior angles of triangle is going that way, not so. But what do I need? I need this to be 90. This is actually another way, I'll show you afterwards. So, can I just leave it as 90 or must I give a reason there? We need to give a reason. So, A, BC is equal to 90 degrees. Why? Angle in semicircle. So, angle C is equal to 180 minus 90 minus x. Why? Sum of triangles. This triangle ABC. So that works out to be 90 minus. You all agree with that? You all okay with that, people? Yes. But I see there was another way of doing it. Without using that 90. Anybody?
C is equals to half.
There we go. Well done. So O1, angle at center, twice angle at circumference. So you see this was 180 minus 2x. And that is half of that, which is 90 minus x. Angle at center, twice angle at circumference. Alright, and then I want you to calculate D. How do you calculate D? How do you calculate D? Half of O1. Not so. Why? Because angle at center is twice the angle at circumference. So angle D is equal to half 180 minus 2x, which is angle at center, is equal to 2 times angle at circumference. So therefore angle D is equal to 90 minus. Okay. Any confusion here? Any confusion? Last question of this exercise. Number 11. You're given NOP is the diameter of circle with center O. So if NOP is your diameter, then what do we know? The angle M2 is 90 degrees as well as the combination of Q1 and 2. Why? Angle in semicircle. Okay? Then we are told that MN is produce its own length. MN produces its own length, which means to say extended to L. LP is produced to cut the circle in Q. Okay? Then N1 is X. Okay, so here must be an X here, which was not written in. I think yes, supposed to have been a 3 there as well. No? Write the following angles in terms of X. Now, importantly here in the diagram, what do you notice? LM is equal to MN. Although it wasn't mentioned here, it's implied there because why it is on the diagram. Okay, you guys understand? Right, so let's go. The first question I want you to answer is P2 in terms of X. There's P2. How are you going to calculate P2? P2? Sum in triangles there. Not so. But what do I need? What do I need, people? M2. So angle M2 is equal to 90. Why? Angle in semicircle. I gave you all the answers already, man. Angle in semicircle. Right. So I'm going to calculate P2. Sum in triangles. So P2 is equal to 180 minus 90 minus X. Sum of triangles. It's triangle MPN. So it's 90 minus X. Okay. Let's look at B. I'm going to take this off because I'm going to try and keep the diagram in focus. B. Angle L. Now at this point you'll see that there's no relationship really that exists here. It's almost evident that it's X. But there's no straightforward geometry there. Not so. However, if I prove that MPN is congruent to triangle MPL, then I can conclude those angles are equal. Because of congruency. What does it mean if two triangles are congruent? They're exactly the same. Okay? They're equiangular. And the angles are the same and the sides are exactly. They can fit exactly onto one another. Okay? So let's look at B. So I'm going to prove congruency. So I say in triangle, LMP and triangle. So it's LMP, so it's NMP. We always try and get the order right from the beginning. So what can we say? Remember there's 4 cases to prove congruency. What are the cases? Side, side, side. Side, angle, side. Angle, angle, side. Right and hypotenuse side. Those are the 4 cases for congruency. Okay. So what can I say first? You say that? MP is a common side. MP is a common side. Then LM is equal to M in Y. That's given to us. And lastly, M1 is equal to M2, which is equal to 90. You see the angles are the same here. Why is that 90? Because there's angles on a straight line. Because that is 90, this has to be 90. Okay. What you was it, Micah? Why is the thing so? Are you okay? Cool. So you can conclude therefore triangle LMP is congruent to triangle NMP. Why? Side, angled side. Can you see? We are used two sides, it must be the included angle. So it's going to be side, angle, side. So if these two triangles are congruent, that means to say that angle L is equal to angle N1, which is equal to x. We know that angle M1 is equal to M2. We also know that the angle P of this triangle is equal to the angle P of that triangle. Can you see that, people? So with that you can conclude, therefore, angle L is equal to x, which is equal to angle N. Why? Because triangle LMP is congruent to triangle NP. Okay. You all okay with that? So then angle L is x. Alright. Let's take this off here as I need the space. Now the question says, you must calculate P3. Now P3, what do I need for P3? I need P1. Why? Because I know the angles on a straight line. But I know angle P1 is equal to the same as P2, which is 90 minus x. Why is that the case? Why is this angle equal to this angle here? Because the two triangles are congruent. And that's hence my reason there as well. So it's going to be 90 minus x. Why? Because triangle LMP is congruent to triangle LMP in P in MP. Or you can say proven above. Okay. So it's going to be 90 minus x. So I'm going to calculate P3. P3 plus 90 minus x plus 90 minus x is equal to that plus is adds up to what, people? 180. Why? Straight line. Straight line. Okay. So angle P3 is equal to 180 minus 90 plus x minus 90 plus x. That cancels, leaves you with 2x. So P3 is 2x. Okay? And the last question, D. They ask you for O1. How are you going to calculate O1? This is not the central angle. So what do I say? Angle at center twice angle at circumference. Can you see that, people? So angle O1 is equal to 2 times 2x, which is 4x. Why? Angle at center is equal to 2 times angle at Okay. So with that, we have concluded
Morning.
exercise
Attention, please.
9.3. Correct?
All grade 8 RCL
It's
nominees.
now more for the weekend. I think I have to study for that.
59
Okay.
at the beginning of break.
Any confusion here?
All grade 8 RCL